Okay, well, this is one of the times that I'm making a video at school. So you might hear some background noise, and that's you, seventh grade. This is chapter 7.3, and we're dealing with expressions. So here we go. Simplify the expression. This is actually a poor wording here. It says expressions. Expressions don't have equal signs, but we notice that we see an equal sign right there. So that's not a very good example of what an expression should really look like. So let's do this. Let's just take this away so we have a better representation of what an expression. That's going to be an expression. And each of these expressions have terms. And that's kind of important also that you need to know. So this is one term. This is a second term. This is the third term. And then this, we'll do it a different color. This is the fourth term. So 1, 2, 3, 4 terms. And then we have like terms. So like terms are these two. These are like terms. They have the same variable to the same exponent. And these are like terms. These are constants. So these two constants are considered like terms. So when we simplify, we're combining like terms. So we have something that's called a coefficient, another important verbiage. So we got vocabulary, we have terms. Then we have like terms. We have coefficients. Coefficients. We have constants. Constants. We have variables. Okay, so these like terms, we're going to combine their coefficients. So if we had to combine them, it's going to look like this: negative 1/3 x plus 1/2 x minus 12 minus 2. Many students like to write it next to each other. We also have something called standard form. Standard form, which puts the variable, it's in order, descending order, alphabetical order, and then variables, and then your constants always come last. So we need a common denominator here before we can combine these fractions. So common denominator would be 6, and then 3 times 6, 3 goes into 6 twice, 2 times 1 is 2, 2 goes into 6, 3, 3 times 1 is 3. So we have negative 26x plus 36x, which produces 16x. And then we're going to combine the negative 12 and negative 2, which makes negative 14. So that is an expression. Notice no equal signs anywhere on the page. Find the sum. Now we have what I call Chewbacca. These parentheses are Chewbacca's. No, that's a bad one. They're Chewbacca's. Both of them. And that says, hey, we have to simplify what's inside before we do the addition. Well, if we look inside, these are unlike terms. This is a variable, this is a constant. So we can't combine those. Okay, so these can't be simplified any further. And then we look inside these parentheses because we're always going to do grouping symbols. And we can't combine these. So what we do is actually distribute this positive into this. There's an invisible 1 there. And when we distribute it, it actually gets rid of both of these parentheses. So you get 5/8 x minus 3. Now, positive 1 times 1/4 x gives us 1/4 x. Positive 1 times negative 11 is negative 11. So now the parentheses have been removed, and now we can combine like terms. We have like terms here. This is a like term with this. Again, we have unlike denominators. So we have to find common denominators. And then our other like terms are our constants. And that's -3 minus 11. So we need common denominators, which is 8. So we'll turn 1/4 into eighths, which is 2/8, -3 minus 11. And let's combine like terms. 5 plus 2 is 7/8 x minus 14. So those are our two answers. Just checking. Good. Okay, now we find the difference, and we still have these parentheses that we have to respect. No, what if I do it really slow? Nope. So we look here. Can we combine those? Nope. Can we combine those? Nope. These are unlike. These are unlike. So we can't simplify within the parentheses. So the other technique of simplifying is we're going to take this. We're going to take this negative and we're going to distribute it into the parentheses. Remember, there's an invisible -1 here. So it's 5/6 x minus 2. And then -1 times 2/3 is -2/3 x. And -1 times -2 is +2. We call that distribution. And we have like terms. And we have like terms. 5/6 x minus 2/3 x minus 2 plus 2. We need common denominators. So 5/6 x minus 6. So 3 goes into 6 twice, times 2 is 4. And -2 plus 2. 5 minus 4 gives us 1/6 x. -2 plus 2 is 0, so you're just left with that. And when I'm converting, that -2/3 x equals how many 6ths x? I'm just looking for equivalency. 3 times 2, so that's why I'm getting that -4 here. Is I'm creating an equivalent fraction. Good. All right, here we see distribution. Now we're going to distribute this term into the parentheses. And so we're going to have 3/5 times 10x plus 3/5 times 5. Do you know why this is plus? Is this plus because this is a plus? No, that's the common misnomer. A lot of students make that mistake. This plus is attached to the 5. So this plus is in front of the 5. This plus is in front of the 3/5. So this is plus because this is a plus. Very, very important for us to understand that this sign here is coming from this term that's being distributed out. And then don't forget the last part of this equation, of this expression, which is 5x. So this just comes down. We distribute to the two terms in the parentheses. And when we do this, don't give me 30x over 5. That's very inefficient. We want to cross cancel. Denominator, numerator, they both have a common factor of 5. And this gives us 3 times 2x or 6x. We're going to cross cancel again. That gives me 1. 3 times 1 is 3 plus 5x. And here are our like terms here. That gives us 11x plus 3. So that should be your answer. And lots of steps, lots of things that you got to do in order. Okay, factor 1/6 out of. So this is really, this is very confusing. I don't like the way that they show this. Whoops. Let's not do that. Let's do white. And let's take that out of there. That doesn't need to be. That's good. So we're going to factor a 1/6 out of here. So I'm going to turn these into products. And we got 2 people. And so we've got this 2 kids that come to my house, X and 1. They both come to my house and they've got something in the bag, and they both are carrying a bag with a 1/6 in it. And so when they come to my house, I'm going to take the 1/6 because that's what they have in common. I'm going to take that from them. I'm going to take the common thing from them. And if I remove that from both of them, what are we left with? If I take the 1/6 from X, you're left with X. If I take the 1/6 from 1, we're just left with 1. So when we factor a term, when we factor out a term, we want to find a common factor, a common term that is, and we got to turn it into multiplication. So we pull it out and notice there's the multiplication now. So it's 1/6. If we redistribute it out, we would get 1/6 times X, which is 1/6X, 1/6 times 1, which is 1/6. So we're turning this into a product. This currently is addition. I want to turn it into a product. When I turn it into a product, I can do a lot of things, a lot more creative things mathematically. So factoring is very important. All right. We have each person in a group buys a movie ticket, a drink, and a popcorn. How much does the group pay when there are 4 people in the group? So we're going to write this 4 times. Each person gets a movie ticket plus a drink plus popcorn, right? Each person, you would add up those costs and multiply it by 4. So we get 4. Movie ticket is $7.50. A drink is $3. And popcorn is also $4. I don't know a single movie theater that would have costs that low. So we can actually add those up to $14.50, and then we're going to multiply it by 4. So $14.50 times 4 is 0, is 20, is 16, plus 2 is 18, is 4 plus 1 is 5. We have 2 decimal places, so we move it there. So the total cost is going to be $58 for 4 people to buy a movie ticket, have a drink, and eat some popcorn. I want to go to the movies now after listening to that and thinking about that. Identify the terms and like terms in the expression. So now we're actually working on the things that I had discussed at the beginning. So identify the terms. So we actually have how many terms here? We have 1, 2, 3, and we have our 4th term. So we have 4 terms here. And terms are separated by addition and subtraction. So we have -9, we have x squared, we have -3x squared, and we have 4x. So if we have to label the terms, we have -9. We have, well, let's label them this way. We have x squared. That's a horrible square. We have x squared. We have -3x squared. That negative is attached to the 3. And then we have 4x. So the terms are -9x squared, -3x squared, and 4x. Now, which ones are like terms? So those have the same variables. So like terms have a couple things. Like terms have the same variable to the same exponent. Now, these have the same variable. These have the same variable, but this is x to the second, this is x to the second, this is x to the first. So the like terms have the same variable to the same exponent. So these are going to be my like terms. So x squared and -3x squared. So you have x squared, and you have negative 3x squared would be my like terms. This is not a like term. So coefficients, the numbers in front, do not determine whether they are like terms. The coefficient for this term is 1, the coefficient is negative 3, and the coefficient is 4. So coefficients don't really matter. It's the variable and its exponent. Simplify the expression, write your answer using decimals. So we got to find the like terms. So that has a h variable. This has an h variable to the first. Those are like terms. And now we have constants, which are also like terms. So if we were writing it, we'd write 4.5h minus 2.1h minus 7.7 plus 9.9. This gives me 2.4h. If we combine these two like terms, and if we combine that, that's plus 2.2. So my expression would be 2.4h plus 2.2. Simplify the expression. So we have to notice the difference between this problem and the other. We can't combine these. These are not like terms. We cannot combine these because this is addition, this is multiplication, and we have to do the multiplication before addition. So we're going to use the distributive property to simplify this. So we'll get 1.4 times p minus 1.4 times 2. And then we have the rest of the problem, plus 9.4. This is not affected because of the parentheses. So this term is only multiplying what's inside the parentheses. But I want you to recognize where we talked about it, this sign is attached to this number. This is a negative here because this is a negative. So check that out. Now we have multiplication. Negative 1.4 times p is negative 1.4p. Negative 1.4 times 2 is negative 2.8 plus the 9.4. We have like terms. These are like terms. They are constants, so we can simplify this expression, which gives us negative 1.4p minus, plus. We have more positives than negatives. And we have 9.4 minus 2.8, borrow. It's going to give us 6, bring down the decimal point. So plus 6.6 is going to be my expression. Negative 1.4p plus 6.6. Factor the expression using GCF. Okay, so let's show how we do this. So remember, we're going to turn this into products. And so this is currently addition, subtraction, 9x. We're going to use the prime factorization, which is 3 times 3 times x. So the prime factorization of 9x is 3 times 3 times x. 15y prime factorization is 3 times 5 times y. So we want the greatest common factor, GCF. The C reminds me to circle the common. So what do they have in common? They have a 3 in common. That's it. That's all they have. So that's going to be my GCF is going to be 3. So I'm going to turn these into products of 3. 3 times what gives me 9x? Well, 3 times 3x. Plus, now I want to turn this into a 3 times what gives me 15y? Well, 5y. That's the neat thing is you see what your products are going to turn into. So you have 3 times 3x plus 3 times 5y. Here are the two kids. They come to my house. They both have a 3, so I'm going to pull out the 3. I'm going to take the 3 from both of those kids, leaving you with 3x plus 5y. If I take the 3 out of there, you're left with 3x plus 5y. And so if we factor this expression, we can turn this addition and subtraction into a product. This is 3 times 3x plus 5y. And it's important, you always want to find the greatest common factor. Factor negative, so this tells you what you want to factor out. That's very interesting. That's not typically going to happen. And typically the number outside is a whole number. You don't do decimal points or fractions. This is actually a little not realistic, but that's okay. So we're going to ask ourselves, negative 2.1 times what would give me 10.5? Well, we could either divide it, and we can go 2.1 divided by 10.5. We're going to move that decimal point one place, so it's 21 over 105, and that's going to give you what, 5? 5? Yeah, 105. So it goes in 5 times. So we turn this into a product with this common factor, and then we want to factor out a negative 2.1. Oh, sorry. Did we notice that? Watch this. This is kind of interesting. So first of all, negative 2.1 times 5 does not give me 10.5b. I actually made a mistake there. And we're going to find out. Everybody's going to make mistakes. Lots of people make mistakes. First of all, it needs to be negative 5. And we had a b that we took out of there that we need to recognize. Now, if we take negative 2.1 times what gives us 18.9, so 21 goes into 189. Does that go in 9 times? Yes, 9. 9. So that's 9 times. 2 kids. I got 2 kids that come to the house. They're trick-or-treating. And in their bag, they have a negative 2.1. Both of these kids, negative 5b and 9. So we're going to take what they have in common out of there. And that leaves us with negative 5b plus 9. I don't like this question one bit because we're not going to ever have a first term negative. So, but it's one of the questions. Sometimes you got to deal with it, and it's asking specifics. So even though it's not very realistic for high school math, we'll do it still. So that's number 11. Let's go to number 12. A rectangular swimming pool has a length of L yards. I like drawing. A length of L yards and a width of 5 yards less than its length. So length minus 5. How much does it cost to border the outside of the pool using 1 yard square tiles that cost $4 each? So what we're talking about is if we're going to border the outside of the pool, we call that the perimeter. The perimeter. So what's the perimeter? Well, the perimeter is going to be 2 times length plus width, correct? So 2 times my length is L, my width is L minus 5, and we can simplify. So that's 2L minus 5. Let's distribute that in, and that gives us 2 times 2L plus 2 times negative 5, and that's going to give us 4L minus 10. So 4L minus $10. That's not in there, is it? 4L minus 6 is as close as we got. So now I'm going to check and see what, because that's the number of tiles. Now I have to multiply it by 4. $4, because it's $4 per tile. So that's 4 times 4L plus 4 times negative 10. That negative is attached to the 10, so it should stay with the 10. That gives us 16L minus 40. Now we go and we check to see. There it is, right there. So notice that I made a mistake, or I wasn't completely done. I read it, I thought I did it, and this really represents the number of tiles. Number of tiles. Oh. Sorry. This represents the number of tiles, and then we, well, no, that doesn't represent the number of tiles at all. This represents the number of tiles. So that's the number of tiles. This is the cost per tile, and that is the total cost in terms of L. A square patio has a perimeter of 8x plus 48 feet. What is the length of the patio? So it's square. So that means it needs to be equal. So every side is going to be the same length. So we know that it's going to be 4. I don't know if you know the perimeter of a square. Let's take that one away. The perimeter of a square is 4s. So what we want to do is we want to factor out a 4 from this. So 8x plus 48. If we can turn this into a 4 times 2x. And if we can turn this into a 4 times, that's 4 times 12. So we get that common factor. So we pull out the 4 and we're left with the 2x plus 12. So what is the length of the patio? Since all 4 sides are going to be this length, so the length of the patio is 2x plus 12. 2x plus 12 feet. 2x plus 12. That's not a 2, Mr. Mack. That's a 12. 2x plus 12 feet would be your answer. That's a good question. I like that one. Here we go. Keep going. We only got a couple more left. So evaluate the expression when x equals 4. So we're going to substitute this value. Substitute this value into wherever we see the variable x. So wherever we see an x, we're going to replace it with the number 4. So negative 4 times, instead of writing x, we're going to write 4 plus 1.5 times 4 minus 2.5 minus 2 times 4 minus 6.5. Now this is the long way to do it. We can do it. It's not a bad way. So that gives us negative 16. This gives us 6 minus 2.5. This gives us negative 8, negative 6.5. This will give us negative 10 minus 2.5 minus 8 minus 6.5. This is negative 12.5 minus 8 minus 6.5. This gives us negative 20.5 minus 6.5, and this gives us negative 27. So evaluate the expression. Now let's talk about how we might have done this a little bit more efficiently. Okay, so let's clone this page. Let's clear the ink. And what I didn't initially understand was, hey, we have like terms here. We could simplify first before substituting. So that's one other technique we can use. So we have negative 4x plus 1.5x minus 2x minus 2.5 minus 6.5. So that's negative 4, so that's 2.5, negative 2.5. That's negative 4.5x minus, that's 9. So now we can simplify. Now we can substitute negative 4.5 times 4 minus 9. That's going to give us 20. That's 16, 18 minus 9, which gives us negative 18.0 minus 9 gives us negative 27. Same answer. Different work, maybe the same number of lines too in simplifying, but just want to put it out there. The populations of 2 cities after t years can be modeled by negative 300t plus 150,000 and 500t plus 200,000. What's the difference in the population of the cities when t equals 6? Well, this is very interesting because I don't know if you notice this. If we can interpret this information, this city is diminishing because as t increases, this is going to be a negative and it's going to eat against that current population. So this city is getting smaller, and this city is actually growing. Not that you needed to understand that or know that, but you should be, that's something you should want to work on, is interpreting information, data. So this city's getting smaller, this city is growing because as T increases, the population increases. This is the current population, and it's increasing 500 per year. This is the current population, and it's decreasing 300 people per year. So what's the difference in populations after T? T tends to stand for years at T6. So let's take the negative 300 times 6 plus 150,000. So that's going to give us negative 1,800 plus 150,000. If we subtract that, that gives us 232,000. Pretty sure that was correct. No. Oh, yeah. No, that's 1,800. 2 zeros, 1,800. I did 18,000. Sorry. That's not correct. That's going to be 1, 4, 8, comma, 2, 0, 0. Yes. There we go. That's better. So that's the population after 6 years. Let's do the other one, which is 500 times 6 plus 200,000. That's going to give us 3,000 plus 200,000, which is 203,000 people. So what is the difference? The difference, we're going to subtract those. So 203,000 minus 148,200. Got to borrow, gives you 8. Got to borrow, gives you 4. 4 from 9 is 5. So the difference is 5,480 people. Yeah, that's good. And I think that's, yes, these are the answer keys. So these are the answers. You can check on the printed material. All right, good luck. Hopefully you understood that.